Okay, everyone. So maybe you've noticed throughout chapter 8 that we've been talking about these things called restricted values, or maybe the problem says don't forget to state restricted values. And you don't remember from Algebra 1 what these restricted values are. Since today is kind of a shorter day, I thought this would be a perfect day for us to kind of come together and talk about these restricted values for an entire day. So what are restricted values? Well, they're the values for x or y or z or q or r that would make the denominator equal 0. We know that you can't divide by 0, and we know fractions are really just, a division problem. So you cannot have the denominator equal 0. The steps are fairly easy for finding them. At least I hope I'm going to make them look presentable for you. The first thing you're going to do, you're going to factor, sorry, that should just say factor. I'll change yours. Factor the denominator, and if you have a division problem, also factor the numerators, which you should kind of be used to already. Step 2, set each of those factored parts equal to 0, and do that before you start canceling stuff like an 8, 4, we factor and cancel. And then solve for the whatever you get, those factored items, and that's what your restricted value is. So let's see that played out. And what I did is I just went online and found some random expressions that had variables in the denominator. So I'm going to do is I'm going to focus on this denominator, and I'm going to focus on the different variables that make up this denominator. So what we'll do is we'll set the first one, x. This can't factor. So if you're wondering why I'm not factoring it, it can't factor. So I know that x to the first power is not allowed to equal 0. So, okay, that's my first restricted value. The other thing I know is that y to the third power is not allowed to equal 0. Well, we learned to solve for y there, you take the cube root. And when we solve for y, that means y is not allowed to be 0. So those are two restricted values for number 1. Now let's take a look at number 2. Again, we're not really concerned about the numerator at all, unless it's a division problem. So number 2, the denominator is x minus 5. It cannot factor. So what I'll do is, because I'm going through my steps, it says factor if you can. I can't factor. So I take my denominator, that's factored. I say it's not allowed to be 0, and then I solve. So if you add 5 to both sides, you get x is not allowed to be 5. So x can be any value except for 5. That's a restricted value. Number 3. So this one's a little more intense because it does factor. Again, I'm not worried about the numerator because the numerator can be anything. I'm worried about the denominator. The denominator is not allowed to be 0. But this one does factor. This one factors by a GCF of 3 and x. So if we take out a 3 and an x, we're left with x minus 7 because you divide by 3 and by x. So now I have two different parts. I have this part and I have this part. So what I'm going to do is let's do the first part. So I say 3x is not allowed to be 0. Divide by 3. X, 0 divided by anything, can't be 3. Sorry about that weird sign. Then I take this part. Remember, if you can factor it, you factor it. You say this part's not allowed to be 0. Solve. Therefore, x is not allowed to be 7 when you add 7 to both sides. So this one has two restricted values because it factored into two separate items. So the restricted values are 3 and 7. So now we'll take a look at number 4. Again, not concerned about the numerator unless it's a division problem. So this does not factor. There's no GCF, and it does not turn into a double parentheses. So I'm just going to say that 3x minus 4 is not allowed to be 0. Add 4. 3x is not allowed to be 4. Divide by 3. X is not allowed to be 4/3 in this particular problem. So that's your restricted value. It's the only one. Let's take a look at number 5. Number 5, there's no you're not concerned about the first numerator, and there's nothing after it to worry about. So you have to factor the denominator. I would ask that you pause the video and try factoring this yourself. However, that is completely your choice if you're going to do that or not. If you pause the video and you're back, you should have got 2x plus 1 and x minus 5 when you factor that using box or grouping or guess and check, however you factor. So since this one did factor, I'm going to ignore this part now, and I'm going to focus on my two new items, so that factor and that factor. So I'll say 2x plus 1 is not allowed to be 0, and x minus 5 is not allowed to be 0. So we have to find the values of x that would cause them to be 0. So subtract 1, divide by 2. So the first restricted value is -1/2, and this one all we need to do is add 5. The other restricted value is positive 5. So again, you factor the denominator and numerators if you have more than one fraction in a division, and then set them equal to 0 and solve. So what I did is I pulled this ridiculous problem that I gave you from the 8-4 notes, and it really actually wasn't that ridiculous. I mean, your factoring skills should probably be that good. So this was the original problem, and all that handwriting below was me factoring it already, I just took a screenshot of the notes, okay? Now, what we're going to need to do is find a lot of restricted values. So we start with the first denominator. That one we need a restricted value from. Now, all of these were denominators, so we need restricted values from each and every one of those. However, we also need a restricted value from this because remember, division flips upside down, so this would be in the bottom, and this, because division flips upside down, this would be in the bottom. So let's go through and find all of those. That would be this, 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 and this. Now, everything I wrote here is from me solving this for you in the chapter 8 notes. I just took a screenshot of the answers. So now what we need to do is find restricted values. The only one that we don't have a restricted value for are these two because those never exist in the denominator. So the final answer to this problem is x plus y over x plus 3y. However, there's a lot of restricted values. So what I'm going to do is I'm going to count them. I'm going to have 1, 2, 3, 4, 5, 6, 7, 8 restricted values. However, we don't need to like double up on any that are doubles. So let's start with number 1, 3x plus 2y. So number 1, 3x plus 2y is not allowed to be 0. Well, that's interesting. There's a double variable here. So let's just go ahead and like get the y on the other side. So we'll say 3x is not allowed to be negative 2y. We can solve for x, or you can just leave it like that. Honestly, you can write x is not allowed to be negative 2/3 y. That really blows people's mind that it's not like an actual number, but it's more like a reference of how x relates to y. So you just take the different pieces, set them equal to 0, and solve. Let's take a look at number 2. So the second restricted value is x minus y. That was a denominator, and it can't be 0. So add the y over. X is not allowed to equal y. Let's look at the third one. The third one says 3x plus y is not allowed to be 0. So let's get x by itself. Or honestly, you could probably get y by itself too. It doesn't really matter to me as long as you like solve for one of the variables. I'll just stay consistent and get x by itself. So I'll do 3x is not allowed to equal negative y, divide by 3. X is not allowed to be equal to negative 1/3 y. Let's look at the fourth one. Ooh, the fourth one is x minus y. I already have that one. That's the same as number 2. The fifth one is 3x minus 2y. So the fifth one. The fifth one is 3x minus 2y, and it's not allowed to equal 0. Let's go ahead and solve for x. So that's 3x is not allowed to equal 2y. Let's divide by 3. X is not allowed to equal 2/3 of y. So that's the fifth one. Let's look at the sixth one. So here's the sixth one. It's x plus 3y. There's a lot here. X plus 3y is not allowed to be 0. So it's x is not allowed to be negative 3y. Let's look at the seventh. Oh, good. The seventh is the same. Does everybody see this? The seventh is the same as the first, so I don't need to resolve it. And the eighth one, come on, the eighth one's got to be the same as something else. Yeah, the eighth one's the same as the third one. So if I want to highlight all of my odd restricted values this time, there's 1, 2, 3, 4, 5 restricted values altogether. And again, I had to do some of the numerators because they were or will be denominators. Let's just do one more for good measure, a little easier this time. I stole this from the practice test. This is a subtraction problem, so I don't need to worry about the numerators. The only time I need to worry about the numerators is if it's a division problem, which this one is not. So I'll factor this. I would encourage you to pause the video and come back and check your factoring. These are the same thing, thankfully. Okay, hopefully you did leave and go try to factor that. You guys know, right, by now, like your factoring skills have to be pretty spot on. Oh, that's an 8. Look at that. I didn't even look at that. Shame on me. They are different. Let's see, this one's going to be, sorry. There you go. Now it's factored. So let's go ahead and go through actually, this is good. Let's go through our different restricted values. So the first one is a minus 6 is not allowed to be 0. That's a cannot be positive 6 when you solve. A minus 3 is not allowed to be 0. That's a not equaling positive 3 when you solve. A plus 1 is not allowed to be 0. So a is not allowed to be negative 1. And a plus 8 is not allowed to be 0. So a cannot be negative 8. So you have 4 restricted values. Just remember your restricted values, you factor if you can, you set each part equal to 0, and you solve for a variable. And that's how you do restricted values.